The length of human pregnancy is known to have a mean of 266 days and a standard deviation of 16 days. This is in general about the population, so we summarize this as mu equal 266 and sigma equals 16. These are the parameters of the population. Based on records from a large women's hospital, a random sample of 25 women who were smoking and were drinking alcohol during their pregnancy and their pregnancy lengths are recorded in the data file. Do the data provide enough evidence to support the well-known fact that women who smoke and would drink alcohol during their pregnancy have shorter pregnancies than women in general? In other words, are more likely to have premature labor. Now, in general, the length of pregnancy is 266 days and the standard deviation is 16. And so, in this case, if mu represents the average length of pregnancy of smoking or drinking pregnancy woman, then the claim is that this pregnancy length is shorter than those of the general population, but the mean pregnancy length for the general population is 266, so the claim is mu less than 266 shorter. So in symbolic form, the opposite of this claim is mu greater than or equal to 266. The statement without the equal sign is the alternative hypothesis. Sigma is known in this case. The standard deviation of the population is known, so we will use the z test for the mean. Technically, we should check normality. We can check to see if the data appear to be normal, but we will assume so. The null hypothesis is the statement of indifference mu equals 266, and the alternative hypothesis is mu less than 266. This is the first step. The second step in the hypothesis testing process is to compute the test statistics. The test statistic z equals x bar minus the null value mu naught divided by sigma divided by the square root of n. And so we would need to know the mean of the sample. The data is given, not the summary, so we would need to open the data to find the mean of the sample. If we bring up the data, we will see 25 numerical values. These are the length, pregnancy length for 25 pregnant women. We then use either Desmos or Excel or Google Sheet to compute the mean pregnancy length of the 25 numbers. Or if we want, we can also add up all the 25 numbers and get the sum, then divide by 25. We will get x bar equals 259.68. The null value is 266. The standard deviation is 16 given, and n is 25. This will give a negative 1.975. This is the critical value. The p-value will be computed using the one-side test, so this is the probability that z is less than negative 1.975. And if we were to use a calculator, StatsCrunch, normal calculator, or a table, we will get a p-value of 0.024. To use StatsCrunch normal calculator, we just simply search StatCrunch normal calculator. The first result in the search entry should show up. We're looking for the probability on the left-hand side of the z-score, negative 1.975, typed negative 1.975 975 in the appropriate box. This is the standard normal distribution, so the mean is 0 and the standard deviation is 1. Leave those two numbers alone and then hit compute. There we have it, the p-value of 0.024. We then compared it to the significance level alpha, which was not given, so we would use 0.05. This value is less than alpha's, therefore we reject the null hypothesis. If we reject the null hypothesis, then we would support the alternative hypothesis, but the alternative hypothesis is the initial claim, so we support the initial claim. Since the original claim does not contain the equal sign, and we reject the null hypothesis, the statement that we would need to write in this particular case, is that the sample data support the claim that women who smoke and or drink during their pregnancy have shorter pregnancy than women in general. They're more likely to have premature labor.